Welcome to the next lesson on trigonometric ratios. So for this lesson, we're going to have two objectives. The first objective is going to be able to define and identify the three trigonometric ratios of an angle or any angle in a triangle. The second is going to be to apply the three trig functions to find missing sides as well as missing angles. So we should probably add that, and missing angles. So we're going to start by labeling each side of the triangle. The way we're going to label them is we're going to label the sides using the terms the opposite, the adjacent, and the hypotenuse. So the way we label is going to depend on which angle that we're looking at. So in this case, we're looking at angle A for the opposite and the adjacent side. So if we look at angle A, so here's angle A, so I'm looking at this angle right here. So the way we're going to identify the opposite side is going to be the part of the triangle that does not touch angle A. So these are the two sides that touch angle A. The side that does not touch it is going to be side A. So this is going to be the opposite side. So now we have, so which one is side A? A is. A is opposite of angle A. Then we can go ahead and find the adjacent side. Okay, so the way I like to find, well, before we find the adjacent side, we can find the hypotenuse. The hypotenuse is going to be the side opposite the 90-degree angle. So this is the hypotenuse. Hypotenuse. There we go. So that means the remaining side is going to have to be the adjacent side. So this has to be the adjacent side. So side B is my adjacent. Now that's if I'm looking from angle A. But what if I was at angle B? So that's what we're going to see in the next one. So if I'm looking at angle B, so angle B is going to be right here. So now that's going to change things a little bit. My adjacent and my opposite are not going to be there anymore. The hypotenuse is going to stay there because the hypotenuse is always the side opposite the 90 degrees. So let's find the opposite side of angle B, whichever side does not touch angle B. So these are the two sides that touch angle B. The side that does not touch it is going to be side B, right? So this would be your opposite side. And since we know the hypotenuse is C, then that means that the adjacent side has to be the leftover side. So this has to be the adjacent side. So opposite, so identify the opposite sides of angle B. This is going to be side B. And identify the adjacent side of angle B, then it's going to be side A. So a trigonometric function, or for short we call it a trig function, is the ratio of two sides of a right triangle. So we have three different trig ratios that we typically use. We have the first one, which is called the sine. So we pronounce this one like sine, right? So we're going to pronounce this guy as the sine. So S-I-N-E. So that's how we pronounce that. And it is made up of the opposite side. Divided by the hypotenuse. Then the next one that we have is called the cosine. So the cosine, so we spell this C-O-S-I-N-E, right? And we pronounce it cosine. And the cosine is made up of the adjacent and the hypotenuse of the triangle. And then lastly, we have the tangent. So this is spelled T-A-N-G-E-N-T. The tangent of an angle is going to be made up of the opposite and the adjacent side. So that might seem like a lot to remember, but typically we use a shortcut known as SOHCAHTOA. So if you notice, I've kind of highlighted those letters, and if you notice, they create this acronym. So S, right, sine, represents O over H, so we say so, right, we just pronounce it as so. So I'm going to write it right under, so we just say so. And then the next one is cosine, right, so if you notice the letter C, and they're equal to the adjacent A over the hypotenuse H, and we pronounce that ka, right, so we're just going to pronounce that ka. So we have so, and then ka. And then the last one we're going to have is the tangent. And you can see that I've highlighted the T, and then it is equal to the opposite O over the adjacent. So then we get toa. So we say so, ka, and then we say toa. So you can use that to help you memorize the 3 trig functions. So I recommend you writing these down a few times just to help you memorizing it. So let's go ahead and look at some examples. So the first example that we're going to do is we're going to find the 3 trig ratios for each angle. So we're going to first start with angle P, right? So angle P is this angle down here. So this is where each angle is going to, where our trig values are going to start from, right? So first thing I need to do is I need to label the sides of my triangle. I need to label what's the opposite side, what's the adjacent, and what's the hypotenuse. Well, the first one we should identify is going to be the hypotenuse. So this guy right here we know is the hypotenuse. Then we can go ahead and label the opposite and the adjacent. So remember how we identified the opposite side? So we've highlighted the 2 angles, the 2 sides that touched angle P. The side that didn't touch it, well, that's going to be your opposite side. So that's got to be the 15. Then the side that's left over, then that's going to be your adjacent side. So the side that's left over, that's your adjacent side. So now that we have our 3 sides labeled, now we can go ahead and complete our trig ratio. So remember that our trig, one way to remember our trig ratio is so katoa, right? So let's write it up. I'm going to write it up on the top. So ka toa. So the sine is the opposite divided by the hypotenuse. So my opposite side in this case is 15. So I'm going to put a 15 here at the top. Well, you know what? Let's write it. It's the opposite sine divided by the hypotenuse. So we know that the opposite is 15, and the hypotenuse we know is 17. So the sine of P, so my final answer would be the sine of P is equal to 15 over 17. All right, let's go ahead and find the cosine. So now my cosine is going to be the adjacent divided by the hypotenuse. All right, so we have the adjacent over the hypotenuse. So we know that the adjacent side is going to be equal to 8. So let's go ahead and replace our adjacent side with 8, and then my hypotenuse is going to be 17. So I end up with my final answer that the cosine of P is equal to 8 over 17. Now let's look at the tangent, right? The tangent is the T, right? My tangent is the opposite over the adjacent side. So tangent of P is the opposite. My opposite side is 15, and my adjacent side we know is 8. So now I know my tangent of P is 15 over 8. So now let's go ahead and look at Q. Right, now I want to look from angle Q. So the hypotenuse stays the same, right? Hypotenuse is always a hypotenuse. But now I'm looking from this side over here, Q. So now I'm here at Q. So the two angles that create Q, the two sides that create angle Q are 15 and 17. So that means that the 8 has to be my opposite side. 8 is my opposite, and the one that's left over has to be my adjacent. So sine of Q is going to be the opposite, so 8 over the hypotenuse, which is 17. My cosine is the adjacent side, in this case 15 over 17, and my tangent of that angle is the opposite side. It's the opposite side over the hypotenuse. Okay, so in the second example, we're going to want to find the sine, the cosine, and tangent ratios for each angle, for R and S. So we're going to go ahead and we're going to start off with our angle R. So let's go ahead, let me write my three ratios out, right? We have sine. I'm going to want to write out the sine of the angle. So we have sine of angle R. We'll put that one there. We have the cosine of angle R. Whoops. The cosine of angle R will go there. And then we have the tangent of angle R as well. Put that there. Perfect. Okay. So next thing I want to do is I want to label my three sides of the triangle, right? I need to know which value goes where. So we know the hypotenuse, right? We can find the hypotenuse right away. We know that is always opposite the 90-degree angle. So this is my hypotenuse. I know that the opposite side is going to be the side of the triangle that does not touch the angle. So if we're looking at angle R, right, angle R never ever touches side R. So that means that side R is going to be the opposite side. And then S, we know, is just going to be the leftover side. So in this case, we're going to have the adjacent side. So this is going to be the adjacent side. Perfect. So let's go ahead and plug the values into the appropriate trig function, and let's see what we get. So the sine of R, so remember we're looking at SOHCAHTOA. So ka and toa, right? So let's see, sine is the opposite over the hypotenuse. So my opposite side is R and my hypotenuse is T. So opposite side is R, my hypotenuse is T. We're just going to go ahead and replace R and T right now with the values that they equal to. So this is going to end up being 8 is my R and my T is 16. I'll write that again a little neater. One more time. Perfect. Now to solve for, now we can simplify this a little bit more by just dividing the top and the bottom by 8. So then this is going to give me 1 over 2. And let me write the simplified version. So the final answer is going to be sine, right? The sine of R is equal to 1 over 2. Perfect. Let's look at the cosine of R now. All right, the cosine of R is equal to, cosine is equal to the adjacent over the hypotenuse. So my adjacent side is S, and my hypotenuse is T. So let's go ahead and replace those values. We know S is equal to a radical 3, and we know T is equal to 16. So I'm going to go ahead and divide the top and the bottom by 8. So I'm going to divide the top and the bottom by 8. And then that is going to give me radical 3, right? The 8s are just going to cancel out, over 2, right? 16 divided by 8 is 2. Perfect. So now I end up with radical 3 over 2. Last one, tangent of R. This is going to be, the tangent is opposite over the adjacent, so R over S. Let's go ahead and replace R. R equals 8, and S is equal to 8 radical 3. Let's go ahead and simplify the numerator and the denominator by dividing by 8, and then I get 1 over radical 3. Well, we have to simplify that, right? So I have to multiply the top and the bottom by radical 3, and we know that is going to give me radical 3 over 3. Okay, so that's for angle R.